Okay, trigonometry A2 level, I want to preface this by first saying that this is just going to be an introduction. We'll just be covering the basics of trigonometry. The most of the formulas that we cover today will already be present on the data booklet. So this should just serve as a sort of revision of AS and just an introduction to trigonometry. Of course, just because these are written in the data booklet doesn't mean you don't have to revise them. I'd recommend revising them because it'll be a lot quicker instead of just like swapping through your pages and then going to the data booklet. It's a lot faster just mentally knowing what these formulas are. So first, since you're an A2, you should know. Trying to find like a pen. I changed my app, so. Yeah, looks like I'll just have to write with this. Okay, sine theta was equal to perpendicular over height. So we're going to consider the right angle triangle, right? We know that this is the hypotenuse, and let's take this as our angle. So you should know all of this, by the way. If you don't, then go back and learn this. So sine theta was this, cos theta was base over height. You know, some people have curly brown hair through proper brushing, or SOHCAHTOA, whatever you use. Perpendicular over base. So let's move on. We know that cos square theta was equal to, this is a brief rundown of AS, 1 minus sine square theta, and we know sine square theta similarly was equal to 1 minus cos square theta, and we know that cos square theta plus sine square theta was equal to 1, right? I hope you guys know why that is because let's just take, for example, let's replace cos square theta with 1 minus sine square theta plus sine square theta, minus sine square theta plus sine square theta is 0, so you'll be left with 1. So we proved it. Okay, that was basically what was that was basically the entirety of AS trigonometry. I hope later on in this video series I'll also be recapping this quadrant. You might remember this as well, where they would ask you to like make it into a trigonometric equation, as in they would ask you to make it in a quadratic equation in terms of a specific trigonometric ratio, like we would have tan square theta plus 2 tan theta minus 1, just as an example, and they would ask you to solve this, and then you have to plug them into the quadrants. So if you don't quite remember that, don't worry, I'll be covering that later in this video series. Today we're just going to be recapping. So I think I can erase this. Okay, so in this new trigonometry in A2, we'll be learning about reciprocal functions. So what I mean by reciprocal functions is we would take this. I hope you guys know what a reciprocal is. So 1 over 2, the reciprocal of 1 over 2 would be 2 over 1. So basically 2. That's what a reciprocal is when you flip a fraction. So there are specific trigonometric ratios, or say functions, that are basically a reciprocal of these three. Reciprocal of either of these three. So let's cover them. So if we do 1 over sine theta, that is equal to saying cosecant theta, right? 1 over, memorize this one, cos theta is equal to saying secant theta. And 1 over tan theta is equal to cotangent theta. So one important thing I forgot to mention, in AS we also learned that tan theta was equal to sine theta over cos theta. So we know cotangent theta over here, right? Cotangent theta over here. This is the same as saying a reciprocal of tan theta. So tan theta is equal to sine over cos. So in your opinion, what would you think cotangent theta would be equal to? Just take a second to think. It would be equal to the reciprocal of this. So while tan theta is equal to sine over cos theta, cotangent theta would be equal to cos theta over sine theta. Yeah, I just forgot to mention that, so here you go. Okay, so let's move on forward. So there are also some formulas in this chapter as well. Now the examiner sometimes will just give you like theta, but sometimes he'll also give you theta plus another a number like theta plus 60, theta plus 70. So there are specific formulas for when that does occur. I think I can get rid of this. There wasn't much of a need anyways, but I'll get rid of this over here. So let's move on. So these are already present in the data booklet. So if you forget them in the exam, don't worry. But I would still recommend like learning them. So sine A plus minus B would be equal to sine A cos B plus minus cos A sine B. Okay, so what do I mean by plus minus? So for example, let's take sine x plus 60, right? So if there's plus over here, this will come in handy later when we cover cos and tan with those compound angle formulas. I'll tell. So since there's plus over here, we'll also add plus over here. So sine, okay, A is equal to x, so sine x cos 60. Since it's plus over here on the left hand side of the equation, we would plus, like add them. So cos x sine 60. So you can put that in your calculator and find the values of cos 60 and sine 60. I should pull up my calculator. Sorry, my calculator was just packed in my bag, so I'll pack it. I did not come prepared for this video. It's a very spontaneous video I decided to make today. Okay, so cos 60 is equal to 1 by 2. So that is equal to saying 1 by 2 sine x. Or actually, in a better way of writing that would be sine x over 2. That's basically the same thing. Sine x over 2 plus, and sine 60 is equal to under root 3 by 2. So under root 3 cos x over 2. And we can join them together by saying sine x plus under root 3, because they share the same denominator, so there's no need to like take LCM. Cos x over 2. So that's your entire, so this entire thing that I just wrote over here is the same as saying this. It will share the same value. So when I was learning this in class myself, I was wondering what was the whole point of this. Like, can we just plug x, if we already know the value of x, why would we need to calculate? Why would we need to specifically find this? Well, this will really help in differentiation and integration, where you have to separate them into terms that only have x in them. They don't have x plus 60, x plus whatever. So that will really help in differentiation and integration. Otherwise, in real life, you would just simply just add 60 to whatever value of x you have. And otherwise, actually, let's cover this. Otherwise, if there was, instead of a plus, there was minus over here. There's minus over here. We would also have to rewrite this as minus. Okay, hope you guys got that. I'm just going to erase this entire example. And let's move on to compound angles for cos. Okay, cos A, okay, plus minus B. So I'm telling you, this will really help. 1 second. Let me just write the equation down and then I'll tell. Cos B minus plus. You guys know, see the difference here? Sine A sine B. So the reason I wrote minus above plus, so the reason for this is if it was A plus B, right, then it would be cos A cos B minus sine A sine B. And if it was A minus B, then it would be cos A cos B plus sine A sine B. So it would basically be the opposite sign. Let's solve another example. We'll do the same thing this time, cos x plus 60. So since I wrote plus, you can already guess what we would write on the right hand side. It would be minus. So we'd have to do cos x cos 60 minus sine x sine 60. So cos 60 was 1 over 2, so cos x, my bad, cos x over 2, okay, minus, remember, minus, and this was under root 3 by 2, and you can, join them together, so cos x minus under root 3 sine x over 2, same thing as saying this. So take care, don't fall for the trap that they wrote A plus B, you'd also say, oh, cos A, cos B plus. Do not fall for that trap. It's cos, if it's plus over here, it'll be minus over here, and vice versa. Acha. Sorry for the interruption. I just got busy with something. So I wrote the equation for tan, compound angles for tan, and this is equal to this. Remember, this was quite hard, right? You might have to refer to data booklet to not mess this up. These two, on the other hand, are quite easy, this and this. But tan A, yeah, this one is quite hard. And I think you guys already understand what minus, plus, and the difference between me writing minus over plus and plus minus is. So I don't think I need to even do an example here. It should be very easy for you guys to figure out. Say this is plus, so this would be minus. Say this is plus, I wrote plus over here. Then this would be minus and this would be plus. So I think we're done with compound angles here. Alright, let's move forward to... Okay, so theta is not... So angles are not always adding, like cos x... It's not always x plus 60 something, right? There's also another format that the examiner gives. Sine 2x or cos 2x. Or... I think, yeah. Tangent 2x, so let me just check. I said tangent 2x. Yeah, I should rewrite that. Tan 2x. Okay, so that's tangent 2x. These formulas are also very important to know, and I'll write them down right now. And I'll explain side by side. Also show my working is how, like, you don't have to, like, work out what sine 2x is every single time I have to use it. But I'll show you guys how it was derived, how it was first found. Anyways, so let's move on to cos 2 theta. So cos 2 theta, if you just want, or cos 2x, if you just want the formula, I'll write that in front of you right now. Man, what is with this pencil? Alright, I'll write it down. It was 2 cos square theta minus 1. 2 cos square x minus 1. So I often say theta x. By theta or x, I mean the angle. So don't get confused there. Right. So how we found that out. So if we write cos, you can skip this part if you don't really want to know, but I'm just showing. So 2x is also the same as saying x plus x, right? You never know what the examiner wants. Someday he may even ask you, explain how cos 2x is equal to this. So it's always best to know. So cos x plus x, right? We apply this formula over here. This entire formula. We apply that over here. So we know that cos a plus b is equal to saying cos x. Because a and b both are x. So cos x. Since it's plus over here, we use minus. So sine x. So this will be cos square x minus sine square x. Okay, cos square theta also can be written in another form, and I'll show that as well. It is not only 2 cos square x minus 1. It is also equivalent to saying 1 minus 2 sine square x. And I'll show how that came to be. So cos square, first let's find this value. Let's prove this value first. So for that, I have to replace sine square x with cos. So beforehand, we already covered what sine square was equivalent to. 1 minus cos square x. Okay, so sign changing, cos square x minus 1. Minus is plus, so plus cos square x. And these two will add together. So we're going to be left with 2 cos square x minus 1. However, we can also replace cos square x with sine x, right? Right, that would also be valid. We can also do that to find the other value. Also, if you don't like this new app that I'm using, then comment. If you like the previous one better, I'll use that one. I just wanted to experiment with this. So cos square, we would replace that with 1 minus sine square x minus sine square x. So 1 minus sine square x minus sine square x. So that will be equal to saying 1 minus 2 sine square x. That's the same thing as what we wrote over here. So it really depends on what the question is demanding. If they, for example, give you cos 2x and they say your final answer should be in terms of sine, right? In terms of the trigonometric ratio, which is sine, then you're going to have to use this value. Otherwise, if it says it should be in the form of cos, or if you just want to keep all your terms in the form of cos, you don't want another sine format in there, then you should use 2 cos square x minus 1. So that's a duality of cos 2x. I'll switch to the next page. Yeah. Okay. Now let's cover sine 2x. So we know beforehand that sine a plus b was equal to sine a cos b plus minus cos a sine b. So we can rewrite sine 2x as sine x plus x, which would be equal to saying, using our previous formula that we learned, sine a cos b, sine x cos x plus cos x, it was sine x, right? Yeah, I'm afraid of getting it wrong on video. That would be embarrassing. So that would be, okay, that's the entire formula. Actually, no, that's not the entire formula. 1 second. These are the same, yeah, sorry. This will be actually 2 sine x cos x. So how I reach that value, so this sine x cos x is this, right? This entire thing over here. This is equal to this. Because they're both multiplying, it's just you have to switch the order at which they're written. So that would be sine x cos x. Look, 2 into 3 is the same as saying 3 into 2. So cos x sine x is the same as saying sine x cos x. So these are the same exact values. So you do 2 sine x cos x. You can simplify it further. This is like what sine 2 theta is equal to. Sorry, sine 2x is equal to. Okay, let's move on to tan 2x. So you know beforehand that tan a plus b, we know this entire formula. So let's rewrite it. Tan, you can just rewrite this as saying tan x plus x, right? So a and b are both x. Tan x plus tan x over 1 minus tan x tan x. So that would be 2 tan x over 1 minus tan square x. You could replace tan with sine over cos, but I wouldn't recommend that. This is just your final answer. You can do that later on. Say the question is not asking you to write this in terms of tan theta, but it's asking you to write in terms of sine or cos. Then sure, you can replace tan with sine over cos. But otherwise, if it's asking you in terms of tan, I wouldn't recommend like changing it to sine cos. Just keep it like this, and that we're done. Right. What other formula was there? Let me think. Yeah, this formula as well. So this formula is not covered that much, but it's nonetheless very important. Cos square x plus sine square x. So you guys must already know what this is equal to. We already covered this in AS, and like we covered this like 5 minutes before. That's equal to 1. Let's divide both sides of the equation by cos square x. So this is a rule of maths, right? If you do anything to one side of the equation, you have to do it to the other side as well. So say I want to divide this entire side by cos square x. So for them, for it to still check out according to the rules of mathematics, I would have to divide this side by cos square x as well. So let's separate these values, cos square x over cos square x plus sine square x over cos square x. Okay, alright, so remember what 1 over cos was? It was equal to secant theta. So first of all, let's write what secant theta or secant x was equal to. It was equal to 1 over cos theta. And I explained just like a minute ago that if you do something to one side of the equation, you're going to have to do the exact same thing to the other side of the equation. So if I want to square secant x, if I want to square it, then I will have to square this side as well. So secant square x is the same as saying 1 square over cos square x. 1 square is equal to 1 either way. And does this remind you of this? So we can replace this with secant square x. Oh, I ran out of space. Okay, well, we'll work with this tiny amount of space. So cos square x over cos square x, these are the same terms, so they cancel out, so that's 1. And sine over cos was tan theta. So, sorry, tan x. So tan square x should be equal to sine square over cos square. So that would be equal to tan square x is equal to secant square x. And I think that's all the basic... Yeah, that's all the basic... one more thing. Yeah, one tiny thing that we should also cover in this video. Remember let me first rotate this page. Yeah, so let's remember what cos 2x is equal to. That was equal to 2 cos square x minus 1. So you can see over here, we divided x by 2. On the left-hand side, it was 2x, but now it's equal to 1. We can apply this for larger values of x as well. This doesn't only apply to 2x. So cos, say we have 4x. So remember I said that over here we divided x by 2 on the right-hand side. Like the right-hand side, we just divided x by 2. Let me just double check. Yeah, we divided x by 2. So we're going to do the same thing. So just predict what we'll have to write over here in the angle. This will be 2 cos square. I'm going to leave this blank. Minus 1. So predict. I said beforehand that we divide x by 2. So we would write 2x over here. And then you would further simplify this as well. Let me just think again. Yeah, you would also further. Also, if you write cos 6x, it would be equal to 2 cos square 3x. And then, it just goes on and on. So 2 cos square 2x, if I remember correctly. So 2 cos square 2x is the same as saying 2 into cos 2x whole squared minus 1. Let's expand cos 2x, so that would be 2 cos square x minus 1 whole squared minus 1. So I hope you guys remember how to open squared. Of course, you must know this. So 4 cos 4x minus... I'm doing this mentally. Actually, for you guys, I'll do it slowly, showing always. So if you remember correctly, it's a square plus... Actually, no. Here we're doing minus 1, so it would be minus 2ab plus b squared minus 1. So a is equal to 2 cos square x. So we place that in its place. 2 cos square x whole squared minus 2 cos square x. b is 1 plus 1. I kind of ran out of space over there. So let's move it over there. So 2 cos square x whole squared would be 4 cos 4x minus 2 into 2 is 4, so minus 4 cos square x plus 1 minus 1. Now we multiply the entire thing by 2, so that will be 8 cos 4. 8 cos 4x minus 8 cos square x plus 2 minus 1. So our final equation, you do not have to memorize what I did over here. This won't be on the data booklet. This might actually come as a question. Expand cos 4x, right? So I'm just, quickly covering this. Minus, I'm just showing you the method of doing this. So we can further simplify this. You'll break it down into this. My chair. So we can compare, say x is equal to, let's take a value, say 30, right? So go to your calculator and okay, this is negative 1 by 2. First of all, I have to check if I did my working correctly. So cos 30 to the power 4 minus 8 cos 30 squared plus 1. Yeah, correct. Okay, so take x is 30. I'm just going to prove that what I did over here was correct. Say take x is 30, so cos 4 into 30. Put down your calculators, it should come as minus 1 by 2. And then I just put this entire thing in my calculator, replacing x with 30 over here, and I got the right value. So this is how you would expand other upper values of x. Alright, so that was the basics of trigonometry. That was basically an introduction to trigonometry. Watch this video over and over again. Again, if you don't like the new app I'm using, then just comment and I'll change it. You should memorize all these formulas. Try memorizing them. If you can't, then it's okay. They'll be on the data booklet. I'm not talking about this page. I'm talking about the entirety of this page and what we did beforehand as well. All this will be on the data booklet, so if you cannot memorize them, I would recommend memorizing them, but if you can't, then don't beat yourself too much about it. They'll be on the data booklet. So that was introduction to trigonometry. In the next video, we'll be covering equation solving. Let me just look quickly. Yeah, equation solving. Also trigonometric identities as well, like identity proving. I'll do that next video as well.